Hello students, our next topic is ray optics. So in this ray optics, we are going to discuss about some of the phenomena like what is the reflection of light, what are the laws of reflection of light. Then we have some mirror and the lens and mirror formulas are there. Telescope optical instruments. So ಇದೆಲ್ಲ points ಅನ್ನ discuss ಮಾಡ್ತೀವಿ. Okay, so lesson in the for NEET exam, what all it is deleted anta helidre. Here again, not much topic is deleted from this. So in the ray optics part, reflection, spherical mirror, mirror formula, and the reflection of light, air, plane and the spherical surfaces, lens makers formula, total internal reflection, magnification, power, then combination of thin lenses, and the magnifying power. So these all points are there in this lesson. Okay. So let us see what you mean by ray optics. So in physics, we have different branches. In one of the in that one of the branches called as what? Ray optics. Optics anta irutte. So optics alli light ಮತ್ತೆ light phenomena ಅನ್ನು discuss ಮಾಡ್ತೀವಿ. So what is ray optics? We will see. Ray optics or geometrical optics. So in this optics, the light is considered as a ray which travels in a straight line. It states that for each and every object, there is an image. So in the case of the ray optics, the light will travel as a straight line anta ಹೇಳ್ತಾರೆ. Here the first application what they are explaining is that is the reflection of light. So what is reflection of light? The bouncing back of light from the same medium and a reflection of light anta ಹೇಳ್ತೀವಿ. So 10th class ಅಲ್ಲಿ ಕೂಡ ಕಲ್ತಿದೀವಿ. That is when the light ray is incidentting on the surface, it will bounce back in the same medium. So this is called as what? Reflection of light anta ಹೇಳ್ತಾರೆ. Okay. Suppose if I draw the perpendicular to this, so this is called as the normal. This is called as the incident ray. This is called as the reflected ray. Okay. So this angle is called as idanna ನಾವು angle of incidence ಅಂತ ಹೇಳ್ತೀವಿ. ಈ angle ಅನ್ನ angle of reflection ಅಂತ ಹೇಳ್ತೀವಿ. So this is the reflection phenomena. ಒಂದ್ ನೆನ್ಪಿಡಿ, ಈ ಆಪ್ಟಿಕ್ಸ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯಾವುದೇ ಡಯಾಗ್ರಾಮ್ ಆಯ್ತು ಪ್ರಾಕ್ಟಿಕಲ್ ಅಲ್ಲಿ ಆಗ್ಲಿ ಅಥವಾ ಇನ್ ದ ಥಿಯರಿ ಎಕ್ಸಾಮ್. ಸೊ ಡೈರೆಕ್ಷನ್ ಆಫ್ ವೇವ್ ಯಾವ್ದು ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಲೈಟ್ ಅದ್ದು, that you need to denote here. Okay. So here this is the symbol. It means that light is traveling from A to B. Suppose if you show like this, then the light is traveling from B to A. Correct? So like this, we need to denote it always. So here we have the next point, that is the laws of reflection. So what is the laws of reflection? That is the first law is angle of incidence is equal to angle of reflection. This is the first law. Then the second law is what? At the point of incidence. So you'll note both the figure alli. This is called as the at the point of incidence. At the point of incidence, the incident ray, the reflected ray, and the normal all lie on the same plane. All lie on the same plane. So this is the second law. Okay. Next ಏನಿದೆ ನೋಡೋಣ. The next point is ದಟ್ ಇಸ್ ಸಪೋಸ್ ನಿಮ್ಮ ಹತ್ರ ಒಂದ್ ಮಿರರ್ ಇದ್ರೆ ಒಂದೇ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಸಪೋಸ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ದ ಮಲ್ಟಿಪಲ್ ನಂಬರ್ ಆಫ್ ಮಿರರ್ಸ್, ಮತ್ತೆ ಆ ಮಿರರ್ ಅನ್ನ ಸಮ್ ಆಂಗಲ್ಸ್ ಅಲ್ಲಿ ಇಟ್ಟಿದೀವಿ. ಓಕೆ, ಸಪೋಸ್ ಟೂ ಮಿರರ್ಸ್ are there, they are placed with some angle. ಸೊ ನೀವಿಲ್ಲಿ ಏನ್ ಇಮೇಜಿನ್ ಮಾಡ್ಬೋದು ಅಂತ ಅಂದ್ರೆ, ನೀವಿಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮಾಲ್ಸ್ ಅಲ್ಲೆಲ್ಲ ವಾಟ್ ಎವರ್ ದ ಟ್ರಯಲ್ ರೂಮ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್, ವಿ ಕ್ಯಾನ್ ಸಿ ದಟ್ ದ ಮಿರರ್ಸ್ ವಿಲ್ ಬಿ ಪ್ಲೇಸ್ಡ್ ಇನ್ ಆಲ್ ದ 3 ಡೈರೆಕ್ಷನ್ಸ್. ಸೊ ಕೆಲವೊಬ್ರು 4 ಡೈರೆಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಇಟ್ಟಿರ್ತಾರೆ. Here this is one mirror, one more angle, this is one more mirror, all are placed at perpendicular to each other. So ee tara iddaga how many images are formed when the one object is placed here? How many images are formed? Yav tara calculate ಮಾಡಬಹುದು ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ಇದೆ ನೋಡಿ. The number of images is given by 360 by theta. This is for the even integer. So 360 by theta minus 1, this is for the odd integers ಅಂತ ಹೇಳ್ತಾರೆ. That is n is equal to 360 divided by theta. So here 360 divided by theta ಅಂದ್ರೆ ಎರಡು ಮಿರರ್ ಮಧ್ಯದಲ್ಲಿ ಎಷ್ಟು angles ಇದೆ ಅಂತ. Suppose here 90 is there, ನೀವು ಇಲ್ಲಿ 90 substitute ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ this is n is equal to 4. So the number of images formed are 4 here. Understanding? So the next phase is reflecting surface. So what is reflecting surface? Reflecting surface ಅಂತ ಅಂದ್ರೆ ಸಪೋಸ್ ನಿಮ್ಮ ಹತ್ರ ಒಂದು ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನೀವೇನಾದ್ರೂ ಇದನ್ನ 2 ಪಾರ್ಟ್ಸ್ ಅಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ದು 2 ಪಾರ್ಟ್ಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ ಇಸ್ ಗೆಟಿಂಗ್ ಡಿವೈಡೆಡ್ ಇಂಟು 2 ಪಾರ್ಟ್ಸ್. ಸೊ one part is called as the concave spherical mirror, one part is called as the convex spherical mirror. Okay, so what is concave spherical mirror? Simple example ಹೇಳ್ಬೇಕಂತಂದ್ರೆ ಸಪೋಸ್ ನೀವೇನು ಬ್ರೇಕ್ಫಾಸ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆಲ್ಲ ಏನ್ ಸ್ಪೂನ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ, that spoon front part what you are seeing, that is the concave ಅಂತ ಹೇಳ್ಬೋದು. Front face ಗೆ concave surface ಅಂತ, and the back side is called as what? The convex spherical mirror. So ನೀವು ಈ ಸ್ಪೂನ್ ಅನ್ನ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಫ್ರಂಟ್ ಫೇಸ್ ಆಫ್ ದ ಸ್ಪೂನ್ ಅನ್ನು ನೀವು ನಿಮ್ ಫೇಸಿಗೆ ಹಿಡಿದ್ರೆ, ಜಸ್ಟ್ ಹೋಲ್ಡ್ ಇಟ್ ಅಟ್ ಡಿಫ್ರೆಂಟ್ ಪ್ಲೇಸಸ್, ಏನಲ್ಲಿ ಇಮೇಜ್ ಕಾಣುತ್ತೆ ಬೇರೆ ಬೇರೆ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇಟ್ಟು ನೋಡಿ. ಒನ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಸೇಮ್ ಸೈಜ್ ಕಾಣುತ್ತೆ, ಅಟ್ ಒನ್ ಪಾಯಿಂಟ್ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಫ್ರೆಂಟ್ ಸೈಜ್. ಸೊ ಲೈಕ್ ದಟ್ the different sizes of the images you can observe in the concave mirror. Same way you can observe in the convex mirror also. Andre back side or the part alli kuda navilli nodbodu. Okay, so here sometimes it will be same size, sometimes it will be bigger, smaller, ಮತ್ತೆ ಕೆಲವೊಂದ್ಸಲಿ ಇನ್ವರ್ಟೆಡ್ ಇರುತ್ತೆ, ಕೆಲವೊಂದ್ಸಲಿ ಸೇಮ್ ಕಾಣಿಸುತ್ತೆ. ನೀವು ಇದೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡಬಹುದು ಯಾವ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಯಾವ ತರ ಕಾಣಿಸುತ್ತೆ ಅಂತ. Next, sign convention. So what is sign convention? See, so what is sign convention? That is, the sign convention is nothing but what? For the mirrors, all the measurements are made from the pole. So actually, ನೀವು ಇಲ್ಲೇನು ಮಿರರ್ ಅನ್ನು ನೋಡ್ತೀರಾ, here we have the sum of the parts. ನಾನು ನಿಮಗೆ ಇಲ್ಲಿ ಹೇಳಬೇಕು ಅಂತ ಅಂದ್ರೆ, okay, so suppose this is, I am taking the example of the concave mirror. ಇದು concave mirror ಇದೆ. So ಈ concave mirror ಅದೇನ್ ಸೆಂಟರ್ ಪಾರ್ಟ್ ಇರುತ್ತೆ, this part is called as the pole. So the center part of the reflecting surface is called as the pole. ಮತ್ತೆ ಇಲ್ಲಿ ಏನ್ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಮುಂದ್ಗಡೆ ಏನ್ ಕಾಣ್ತಾ ಇದೆ ಅಂದ್ರೆ ನೀವು ನಿಮ್ ಫೇಸ್ ನೋಡಿದಾಗ ಯಾವ ಪಾರ್ಟ್ ಕಾಣಿಸುತ್ತೆ, ದಟ್ ಪಾರ್ಟ್ ಇಸ್ ಕಾಲ್ಡ್ as the aperture. It is called as the aperture. So pole ಆಯ್ತು, aperture ಆಯ್ತು. Next, here one ಸೆಂಟರ್ ಪಾರ್ಟ್ ಇಸ್ ದೇರ್. ಅಂದ್ರೆ ನೀವು ಇದೇನ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಇದೆ ಇದನ್ನ ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ ಇಲ್ಲೊಂದು ಸರ್ಕಲ್ ಡ್ರಾ ಮಾಡಿದ್ರೆ whatever the center you are getting, so the center is called as center of curvature anta ಹೇಳ್ತಾರೆ. It is called as the center of curvature. So what is center of curvature? Center of curvature is the center of the spherical mirror which forms the part of the reflecting surface. So center of curvature andre it is the center of the spherical mirror which forms the part of the reflecting surface is called as what? Center of curvature. Next, ಈ ಪೋಲ್ ಮತ್ತೆ ಮತ್ತೆ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಮಧ್ಯದಲ್ಲಿ ಏನ್ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ, ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಡಿನೋಟೆಡ್ ಆಸ್ ಆರ್. ಓಕೆ, ಸೊ ನಾವಿಲ್ಲಿ ಫಸ್ಟ್ ಪೋಲ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಅಪರ್ಚರ್, ಥರ್ಡ್ ಪಾಯಿಂಟ್ ಇಸ್ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್, and the fourth part is radius of curvature. Then the fifth definition. So fifth definition is the line passing through the center of curvature and the pole. So center of curvature ಮತ್ತೆ pole ಮಧ್ಯದಲ್ಲಿ ಏನ್ ಲೈನ್ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ, that is called as the principal axis. It is called as the principal axis. Okay, so pole, aperture, center of curvature, radius of curvature, principal axis. Next, so on the principal axis we have one point F ಅಂತ, ಇದನ್ನ ಫೋಕಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. What is this focus? Focus ಅಂತ ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಇಂದ ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ when the light radiations will be incidenting on the this surface, ಇದೇನಾಗತ್ತೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗತ್ತೆ. ಹೌದಾ, ರಿಫ್ಲೆಕ್ಟ್ ಆಗತ್ತೆ. Here the point on the principal axis from where you feel that the lines are getting diverged or the lines are getting converged. ಸೊ ಆ ಪಾಯಿಂಟ್ ಇಂದ ಲೈನ್ಸ್ ಕನ್ವರ್ಜ್ ಆಗ್ತಾ ಇದೆ ಅಥವಾ ಆ ಪಾಯಿಂಟ್ ಇಂದ ಲೈನ್ ಡೈವರ್ಜ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಕಾಣಿಸುತ್ತೆ. ದಟ್ ಪಾಯಿಂಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಫೋಕಸ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸಿಕ್ಸ್ತ್ ಡೆಫಿನೇಷನ್. Seventh definition is what? That is the focal length. So what is focal length? Focal length is nothing but what? Focal length is the distance between the focus and the pole. The distance between the focus and the pole is called as the focal length. Correct? So total ನಮ್ಮ ಹತ್ರ 7 definitions ಬರುತ್ತೆ. So ನಿಮ್ಗೆ all the 7 definitions ಗೊತ್ತಿರಬೇಕು. Pole, aperture, center of curvature, radius of curvature, principal axis, focus, focal length. Yes. So these are the 7 definitions which we study here. Okay, then next. So ಇದು ಗೊತ್ತಿದ್ರೆ ನಿಮ್ಗೆ sign conventions ಅರ್ಥ ಆಗುತ್ತೆ. You can see now. So here you can see the following are the sign conventions. So what are the sign conventions? See here. All the distances are measured from the pole of the mirror and the distance measured in the direction of the incident line are taken as positive. Yeah, and in the other words, the distance measured towards the right of the origin are taken as positive. Antandre, here whatever the object you are using, whatever the measurement, ಅಂದ್ರೆ ನಿಮ್ದು ಇದು ಪ್ರಿನ್ಸಿಪಲ್ ಎಕ್ಸಿಸ್ ಆಯ್ತು, ಇದು ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಗೂ ಸೇಮ್ ಬರುತ್ತೆ. ಸೊ ಹಿಯರ್ ದಿಸ್ ಇಸ್ ದ ಕಾನ್ಕೇವ್ ಮಿರರ್. ಸಪೋಸ್ ಹಿಯರ್ ಐ ಆಮ್ ಕೀಪಿಂಗ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಂತ ಅಂದ್ರೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, ದಿಸ್ ಇಸ್ ಯುವರ್ ಪೋಲ್. ದ ಮೆಜರ್ಮೆಂಟ್ಸ್ ಆರ್ ಮೇಡ್ ಫ್ರಾಮ್ ದ ಪೋಲ್. ಅಂದ್ರೆ ನೀವು ಇಲ್ಲಿಂದ ಇದು 0 ಅಂತ ತಗೊಂತೀರಾ. ಸೊ 0 1 2 3 ಲೈಕ್ ದ್ಯಾಟ್. ಬಟ್ ಇನ್ಸಿಡೆಂಟ್ ರೇ ಯಾವ್ದು ಎಲ್ಲಿಂದ ಇರುತ್ತೆ, ಇದು ಆಬ್ಜೆಕ್ಟ್ ಅಂದ್ರೆ ಇದ್ರದ್ದು ಲೈಟ್ ಇಲ್ಲಿ ಮಿರರ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಹೌದಾ? So this is the incident ray direction, but you are doing the measurement in the opposite direction. So this is called as what? When you are doing all the measurements from the pole, but when you are doing the measurement from the pole, but it is opposite to the direction of the incident ray, then the distances are taken as what? Negative. Then opposite, when you are doing the measurement along the direction of the incident ray, then it is taken as positive. Okay. So it is like your origin. So ನೀವೇನ್ axis graph study ಮಾಡ್ತೀರಾ, x axis, y axis, minus x axis, minus y axis. So this side measurements are taken as positive, ಈ ಕಡೆ measurements negative. Upside measurements are taken as positive, below measurements are taken as negative. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, so principal axis above ಅಂದ್ರೆ principal axis ಮೇಲ್ಗಡೆ ಏನ್ measurement ಮಾಡ್ತೀರಾ, this one, this is taken as the positive values. Suppose if you do in the down, then it is taken as the negative values. So positive and the negative measurements. Okay. So here we have the 5 points. First, all the measurements are done from the pole. Second, along the incident ray direction, measurements are taken as positive. Opposite to the direction of the incident ray is taken as negative. Third. Fourth, above the principal axis, measurements are taken as positive. Below the principal axis, measurements are taken as negative. Okay. To the next point. So mirror formula. So see what is mirror formula. The mirror formula is nothing but which is connecting between the object distance, image distance and the focal length is called as the mirror formula. So object distance andre from the object to the pole object distance, from the pole to the image is called as the image distance. So focal length ನಿಮ್ಗೆ already ಗೊತ್ತಿದೆ. The relation between these three which will connect the u, v and f. So u is the object distance, v is the image distance, f is the focal length. It is taken as 1 by v plus 1 by u is equal to 1 divided by f. Okay. Then the focal length is given by r divided by 2. This is the relation between focal length and the radius of curvature. So focal length is the half of the radius of curvature value, or the radius of curvature is twice of the focal length anta kuda heltivi. Then we have the magnification. So the linear magnification is there. So magnification is defined as the height of the image to the height of the object anna magnification anta heltivi. ಮತ್ತೆ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಹೇಳ್ಬೇಕಂದ್ರೆ the distance image distance to the object distance minus. So this is called as, this is also called as the magnification. So magnification anna focal length alli kuda baribodu, that is given by f divided by f minus u. ಮತ್ತೆ ನಿಮ್ಮ ಹತ್ರ image distance ಇದ್ರೆ it is f minus v divided by f. So please take down these two formulas. So this is not there in your book. Okay, so first two ಕೊಟ್ಟಿದ್ದಾರೆ, third fourth you don't have it, just take down the formula also. Then next we have the magnification. If it is negative correspond to real image, and if the value is positive then it is a virtual image anta ಹೇಳ್ತಾರೆ. So this is all comes under the reflection. Then we have the refraction phenomena. So see what is refraction. Refraction is nothing but what? The when the light is traveling from one medium to other medium, it will change the direction of propagation. So this is the medium, this is the incident ray, and this is the normal drawn. ಇದು ಏರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ, ದಿಸ್ ಯು ಕನ್ಸಿಡರ್ ಇಟ್ ಆಸ್ ಗ್ಲಾಸ್. ಸೊ ಒಂದ್ ಮೀಡಿಯಂ ಇಂದ ಮತ್ತೊಂದು ಮೀಡಿಯಂ ಬರ್ಬೇಕಾದ್ರೆ ಇದೇನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಚೇಂಜ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಿಗೇಷನ್. ಸೊ when the light is traveling from one medium to other medium, the light will change the direction of its propagation. That is called as the refraction phenomena. Andre same line al baralla, it will just take different path. So this phenomena is called as what? Refraction of light. So ಯಾವ ರೀತಿಯ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡುತ್ತೆ, that is depending on the medium. For example, suppose if you consider this is air medium, this is glass medium. Okay, so this is the incident ray, so this is the refracted ray, this is the normal drawn. So when it is traveling from air to glass, it will bend towards the normal, andre normal towards bend ಆಗುತ್ತೆ. When it is traveling from glass to air, ಆ ಟೈಮ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅವೇ ಫ್ರಮ್ ದ ನಾರ್ಮಲ್ ಇಟ್ ವಿಲ್ ಬೆಂಡ್, ಅವೇ ಫ್ರಮ್ ದ ನಾರ್ಮಲ್. ಅಂದ್ರೆ ರೇರರ್ ಮೀಡಿಯಂ ಇಂದ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ಬೇಕಾದ್ರೆ ಇಟ್ ವಿಲ್ ಬೆಂಡ್ ಅವೇ. ರೇರರ್ ಟು ಡೆನ್ಸರ್ ಇಟ್ ವಿಲ್ ಬೆಂಡ್ ಟುವರ್ಡ್ಸ್ ದ ನಾರ್ಮಲ್. Denser to rarer it will bend away from the normal. Okay. Next, so in case of the refraction also we have the some of the laws, like the first one, at the point of incidence the incident ray, the normal drawn and the refracted ray at the point of incidence they are on the same plane. So in the same plane anta helbodu. This is the first one. Second one, sine of angle of incidence to the sine of angle of refraction, ಇದು ಕಾನ್ಸ್ಟಂಟ್ ಅಂತ ಆಗುತ್ತೆ. ಸೊ ಇದು ಕಾನ್ಸ್ಟಂಟ್ ಅನ್ನ ನಾವು n ಅಂತ ತಗೊಳ್ತೀವಿ. So this n is called as what? That is the refractive index. So this constant is said to be what? Refractive index. It is denoted by n. So ನಾನು ನಿಮ್ಗೆ ಈಗಷ್ಟೇ ರೇರರ್ ಮೀಡಿಯಂ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಂತ ಹೇಳಿದೆ. Then if this n value, so ಇದೇನ್ n value ಇದೆ, depending on the n value, we can define it as a denser medium or we can define it as a rarer medium ಅಂತ ಹೇಳ್ತೀವಿ. So denser ಅಂತ ಅಂದ್ರೆ n value ಇದೇನ್ refractive index value ಇದೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ, rarer ಅಂದಾಗ it will be less. Okay. So in some of the books it is denoted by n, some of the books it is denoted by mu also. So here some of the standard values are also there. N is equal to 1 ಅಂದ್ರೆ ಇದು air ಗೆ ಆಗುತ್ತೆ. N is equal to 1.5 ಅಂದ್ರೆ ಇದು glass ಗೆ ಆಗುತ್ತೆ. N is equal to 1.33 andre it will be for the water. Correct? So this is what the refractive index. Here, whatever you are writing, that is sin I divided by sin R. Sin I divided by sin R is equal to n. This is called as what? Snell's law. Idanna Snell's law anta ಹೇಳ್ತೀವಿ ನಾವು. Okay. Then the next point we have, that is the critical angle. And the next phenomena is total internal reflection. So see what is TIR, total internal reflection. When a ray of light So TIR. So what is total internal reflection? So total internal reflection anta andre, yes, see this figure, it will be clear to understand. So see here, you can observe this. ಇಲ್ಲಿ ಕೆಳಗಡೆ ನೀವೇನ್ ಬ್ಲೂ ಶೇಡ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is water ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. So this you can consider it as water. Whatever above you are seeing, this you consider it as air. Okay, so ಇಲ್ಲಿ water ಅಲ್ಲಿ you are keeping one object. Consider one object is placed in the water. So compared to water and air, which is rarer medium, which is denser medium? So that is water is the denser medium and air is the rarer medium. So here first in total internal reflection, if you have to say, it should be the ray should travel from denser medium to rarer medium. Okay. So here the ray is traveling from denser medium to rarer medium. That is from water to air. So first line nodi, whatever the first line you are observing here, see this first line. It is going straight. It is traveling straight. What is the meaning of this? That is the ray is passing. ಮತ್ತೆ ಇದೇನಿಲ್ಲಿ interface ಇದೆ, ಇಲ್ಲಿ normal incidence ಆಗ್ತಾ ಇದೆ. Here it is showing the normal incidence. So for the normal incidence, it is going the normal reflection itself. So normal andre without changing the direction, it is just traveling in the next medium. Why? Because the angle of incidence is 90 degree, the angle of refraction is also 90 degree. See the next line. So ಇಲ್ಲಿ next line ನೋಡ್ತಾ ಇದ್ದೀರಾ, it is showing some angle. So the normal ತೋರಿಸಿದ್ದಾರೆ ಇಲ್ಲಿ, ಮತ್ತೆ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, it is deviating ಅಂದ್ರೆ ಇದು ಸ್ವಲ್ಪ change in the denser to rarer, so therefore away from the normal it is bending. The third line, ಇದ್ರದ್ದು ಏನಾಗಿದೆ, ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಸೆಕೆಂಡ್ ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ. ಸೊ ಫಸ್ಟ್ 90 ಇತ್ತು, ಸೆಕೆಂಡ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದೆ, ಥರ್ಡ್ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದೆ. ದಟ್ ಟೈಮ್ ಹಿಯರ್ ದ ರೇ ಈಸ್ ಜಸ್ಟ್ ಗ್ರೇಸಿಂಗ್ ದ ಸರ್ಫೇಸ್, ಅಂದ್ರೆ ರೇ ಏನಾಗ್ತಾ ಇದೆ ಇಲ್ಲಿ ಜಸ್ಟ್ ಸರ್ಫೇಸ್ ಗೆ ಟಚ್ ಆಗಿ ಹೋಗ್ತಾ ಇದೆ. ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ ಶೋಯಿಂಗ್ ದ 90 ಡಿಗ್ರಿ ರಿಫ್ರಾಕ್ಷನ್ ಅಂತ ಹೇಳ್ಬೋದು. The next ray, whatever it is coming, instead of showing the refraction, it will bounce back in the same medium. So next ಮತ್ತೆ ಏನಾದ್ರು ray consider ಮಾಡಿದ್ರೆ that will be also traveling in the same medium ಅಂದ್ರೆ reflection ಅನ್ನೇ ತೋರಿಸುತ್ತೆ. So this type of phenomena is called as what? Total internal reflection. So how you can define this total internal reflection? Yield condition must and should. One, the ray should travel from denser medium to rarer medium. The second is what? That is the angle of incidence must be greater than the 90 degree. ಇದೆರಡು must and should condition ಅಂತ ಹೇಳ್ಬೋದು. So TIR, when a ray of light traveling from denser medium to rarer medium is incident at the interface of two medium at an angle greater than the critical angle of for the two media, the ray is totally reflected back to the denser medium. This phenomena is called as what? Total internal reflection. Yes. Then the next point is that is the principle of reversibility. So what is principle of reversibility? Principle of reversibility is nothing but what? It states that when a final path of the ray of the light after any number of reflections and refraction is reversed, the ray retraces its entire path. So reflection ಮತ್ತೆ refraction ಆದ್ಮೇಲೆ ಮತ್ತೆ ನೀವೇನಾದ್ರೂ ray ಅನ್ನ retrace ಮಾಡಿದ್ರೆ the ray will travel the same path. That is called as what? Principle of reversibility ಅಂತ ಕರಿತೀವಿ. Okay. So refractive index, already this point we have discussed. Here we have the relative refractive index, that is nothing but with respect to the two medium, we will just define it. Then here we have the refraction formula. We are not deriving this. So we are just going through the formula here. Suppose if you consider the mirror and the object is placed at the distance of u and the image is forming at the distance of v, and one is having the refractive index mu1 and one is having the refractive index mu2. In that case, here the refraction formula is given by mu2 by u v minus mu1 by u, which is equal to mu2 minus mu1 is equal to r. Okay, so this is the refraction formula anta helbodu. Okay, so this is entirely related to the mirror. The next part is that is for the lens we have. So the lens is nothing but what? Mirror ಅಲ್ಲಿ ಏನಿತ್ತು ಬರೀ one part ಇತ್ತು. Lens ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ two parts will be there. So here the two reflecting surfaces are combined together. It will form a lens ಅಂತ ಹೇಳ್ತಾರೆ. So lens ಅಲ್ಲಿ ಕೂಡ ನಮ್ಮ ಹತ್ರ ಎರಡು types ಇದೆ. That is the convex lens and the concave lens. So see what is convex lens and what is the concave lens. So here you can see some three figures there. Convex lens and for the concave lenses. So convex lens ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ here three types they are showing. That is a double convex lens, plano convex lens, concavo convex lens. So double convex lens ಅಲ್ಲಿ ಎರಡು concave part ಅನ್ನ ತಗೊಂಡು they will combine. That is called as the double convex lens. Plano convex lens, one surface will be plane and the one more surface will be convex. That is called as the plano convex. Concavo convex lens. So one is concave surface, one is the convex surface combined together forms the lens that is called as the concavo convex lens. So concave convex ಆಯ್ತು, convex lens ಅನ್ನು converging lens ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. Next we have the concave lens. Concave lens is also called as the diverging lens. ಇಲ್ಲಿ ಕೂಡ three types ಅನ್ನ ನೋಡ್ತೀರಾ. So ನಮ್ಮ ಹತ್ರ lens makers formula, again derivation part we are not seeing here, only the formula is there. So 1 by f is equal to mu minus 1 inside the bracket 1 by r1 minus 1 divided by r2. So r1 and r2 are the radii of curvature. Mu is called as the refractive index with respect to the two medium. Okay. So ಇದೇನ್ lens makers formula ಇದೆ, the lens makers formula they are using it for the preparation of the lenses. So ನಾವೇನ್ lens specs ಅನ್ನು use ಮಾಡ್ತೀವಿ based on the radius of curvature or the focal length, they are using this formula for the manufacturing of the lenses ಅಂತ ಹೇಳ್ತೀವಿ. So in case of the lens also we have the magnification. So ಇಲ್ಲಿ ಕೂಡ magnification, height of the image to the height of the object, and it is also written as V by U, or it is also called by given by F divided by F plus U and F minus V divided by F ಅಂತ ಹೇಳ್ತೀವಿ. So this is regarding the magnification. So ನಿಮಗೆ objective ಅಲ್ಲಿ theory exam ಅಲ್ಲಿ ಕೂಡ ಇದು ಬರೋ chances ಇದೆ. That is, if the magnification is greater than 1, the image is magnified. If the magnification is less than 1, the image is diminished ಅಂತ ಹೇಳ್ತಾರೆ. Okay. Then we have the power of the lens. The power of the lens P is equal to the reciprocal of the focal length. SI unit of the power is called as what? Diopter. So SI unit of power is called as what? Diopter. Okay. So here the power of combination of power is given by P is equal to P1 plus P2 plus P3 plus so on up to Pn. Similarly for F is equal to, and the focal length reciprocal of power. So just reciprocal. So this is regarding the power of the and the focal length of the lens for the combination. Then prism formula is there. So what is prism formula? See. So this prism formula, here we have the prism is nothing but it is again the bounded surface. So in case of the prism, we have two triangular faces and the three rectangular faces are combined. That is called as the prism. So adanna ನಾವು prism ಅಂತ ಹೇಳ್ತೀವಿ. Okay. So here we are defining one more definition, that is the deviation ಅಂತ ಒಂದು definition ಅನ್ನು ಕಲಿತೀವಿ, angle of deviation. So what is angle of deviation? So when the light is passed through the prism, so ಯಾವಾಗ prism through it light pass ಆಗುತ್ತೆ, so that is, this is called as the incident ray, this is the refracted ray, this is the what we can say, that is the emergent ray. Suppose if I extend my incident ray in the forward direction, if I extend the emergent ray in the backward direction, here whatever the angle is forming, ಇಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ ಬೇಕಾದ್ರೆ, this angle. So illen angle ಕಾಣಿಸ್ತಾ ಇದೆ ನಿಮಗೆ. This is the extended incident ray, this is the extended emergent ray. So illen angle form ಆಗ್ತಾ ಇದೆ, that is called as the angle of deviation. Okay. So the refraction through the this for derivation is important from your board exam point of view also. Okay. You can see this. Here we have the angle of incidence, angle of refraction, angle of emergence, and angle of deviation. So ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ prism ಫಾರ್ಮುಲಾದಲ್ಲಿ ನಾವು refractive index n ಅಥವಾ mu is equal to ನಾವು ಇಲ್ಲಿ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ. That is given by, that is mu is equal to sin of a plus delta m by 2 whole divided by sin of a by 2. So ಇಲ್ಲಿ a ಅಂದ್ರೆ ಏನು? A is nothing but the angle of the prism. Delta m is the angle of minimum deviation. Okay, so that is for the prism formula. So here we have some of the points like image formation by a concave mirror. So we have a concave mirror and the object is placed at different places. So when the object is placed at the different places, let us see what is the image formation. Here we have the object is at infinity the image is at the focus. When the image is at, sorry, the object is behind the point C, then the position of the image is between F and C. You can also see the nature of the image. It is all the cases real and inverted. Last al matra enagate virtual ಮತ್ತೆ erect anta barutte. What is that condition? The object must be between the F and P. The same way it is for the convex